This is a Loom Solar 20-watt panel. As you can see, this is a polycrystalline one. Two types of solar panel are available: polycrystalline and monocrystalline. This solar panel's color is deep blue. It means it is polycrystalline. The monocrystalline one looks darker than this. And here is the specifications of this solar panel. As you can see, open circuit voltage of this panel is 22.5 volt. Short circuit current is 1.11 ampere. Maximum power current is 1 ampere. We are going to check all these parameters by ourselves. Here is a small box. Behind this, these are our connections. As you can see, here are two terminals. One is for positive and one is for negative. There is no screw in the box. You can easily connect or disconnect this. Outer casing of this panel is made using this aluminum channel. Quality of this aluminum channels are very good. It makes it rough and tough for outdoor purposes. I will put the link of this solar panel of Loom Solar and Amazon in the description box. In Loom Solar website, this panel cost around 1400, and Amazon price I don't know this time. I had bought this from Amazon. There is a protective shield on the solar cells. I don't know what this material is, but this is definitely not glass. Maybe this is something acrylic or plastic kind of. You can see top surface of the shield is not smooth, so this is not glass definitely. So let's check its all parameters using a multimeter by ourselves, and let's see how to charge a small 3S lithium ion battery using the solar panel and a buck converter. It's around 12 am. The sun is exactly over the head, and I have placed this solar panel facing upward. Let's check its voltage and other parameters. I had connected a long wire with the solar panel, and the end of the wire is connected with this multimeter. As you can see, this panel is currently producing 20.4 volt, which is a bit less than what's mentioned, but it fully depends on the condition of the light and other things. So this is pretty much acceptable. Now let's check short circuit current of this panel. To check short circuit current, you just have to short these two positive and negative wire together. Remember, this process is not harmful for solar panel. You can't check maximum output current of a battery or a SMPS in this process, but you can definitely check it in case of solar panel. So I had sorted the positive and negative wire of the panel together. Now grab my multimeter. It is in DC current mode now. Make the value 0 and clamp the wire. As you can see, the maximum output current is 1.069, 1.07 ampere, which is more or less the same what's mentioned in the solar panel before. So it's okay. So now we have a solar panel which is producing around 20 volt DC, but this voltage is not stable. This voltage fluctuates, depends on light or other things. Suppose you have to charge a 12 volt battery, or you want to run this kind of load like this 12 volt bulb or 12 volt motor. In these cases, we don't need 20 volt. We need maximum 12 volt, but we need current more than 1 ampere. So what we can do? In these cases, you can use a solar charge controller which monitors the voltage of the battery and control the charging discharging of your battery using the solar panel, or you can simply use this kind of buck converter. Although this is not recommended for long run, but you can definitely use this for some cases. So let me show you how to do connection of this kind of a buck converter. This is a 20 ampere buck converter, cost something around 250 to 350 in local market or online. This is a constant voltage, constant current type of buck converter. It means you can control both voltage or current in this converter. Here are two potentiometer. One potentiometer is marked as CV. It means constant voltage. This potentiometer controls the voltage, and this potentiometer is marked as CC. It means constant current. Turning this potentiometer, you can set the maximum limit of current this module will pass. If you set the maximum current level in this buck converter, it will never exceed the maximum current level. To keep the current flow under what's rated, it will automatically decrease the voltage. This is a good safety feature of this kind of buck converter. So let's check out the connections. There is total 4 screw terminals. 2 are here and 2 are here, as you can see. So here beside this screw terminal, you can clearly see in plus and here is a in minus, it means this side is input, and in plus it means this is input positive, and in minus it means this is input negative. Here is a switch also, but I don't use this. I always used to keep this on position. Now you can see the switch also clearly, and this size you can see it's marked at out plus, it means this is output positive, and here is out minus, it means it's output negative here. So you have to connect the solar panels output wire in the input of the buck converter, and you will get constant voltage, constant current output in this output side. Now I had connected the wires of solar panel in the input side of the buck converter, and in the output side of the buck converter I had connected this multimeter. At this moment the buck converter's output is around 2.8 volt, it's exactly 2.79 volt. So let's change the voltage into 12 volt. To change the output voltage of the buck converter, we have to turn the CV knob of the buck converter. So let's turn it. I'm turning it clockwise, and as you can see the voltage is rising now. I am setting its output value around 12.6 volt, because we have to charge a 3-cell lithium ion battery which full voltage is 12.6 volt, so it's 12.6 volt also. Now I am running this 555 motor directly from this solar panel using this buck converter. So let's check its voltage and current consumption. At now here is around 12.6 volt, as you can see in this multimeter. Let's check the current. At first make the value 0 and clamp the wire. As you can see, this motor is currently drawing 270 milliampere of current. Let's check the opposite side, which is directly connected with the solar panel, and this side we can see 215 milliampere of current. In the input side of the buck converter we are getting 19.54 volt, which is coming directly from the solar panel, and the output side voltage is around 12.6 volt, which is directly going to the motor. It means from solar panel we are getting higher voltage and lower current, but this buck converter is converting it into lower voltage and higher current. In this way we can reduce the voltage and increase the current. So now let's see how to control the maximum amount of current using the CC pot in this buck converter. To control the maximum output current, you have to turn the CC pot, which is the second one. Now I am sorting the two outputs of the buck converter together, and here is my clamp meter, which is clamped in one wire, and here it's now showing 761 milliampere. It means now the pot is set to maximum output current of 762 milliampere. So I am rotating the pot clockwise, and you can see the current is increasing. Let's set it into 2 ampere. Now the maximum current value is set at 2.036 ampere, which is 2 ampere more or less. So now this buck converter will supply less than or equal to 2 ampere, not more than 2 ampere. So this is how you can set the maximum current limit. I had set the maximum current output of this buck converter in 2 ampere because I want to charge this lithium ion battery pack using the solar panel and the buck converter. Each cell of this battery pack have 2600 milliampere capacity. To charge this battery pack in 1C, we have to provide 2600 milliampere, which is 2.6 ampere, but I want to charge it less than 1C because that is better for long run. That's why I had set the maximum current output is 2 ampere. Now let me show you how to charge this battery. As you can see, output of the buck converter is set to 12.6162 volt, which is the perfect fully charged voltage of a 3-cell lithium ion battery pack. Now our battery pack's voltage is 11.41 volt. You can see the red LED is glowing because this buck converter is currently connected with the solar panel. It means it's turned on now. To charge the battery pack, simply connect the battery's negative terminal to the buck converter's negative terminal and positive terminal of the battery with the positive terminal of the buck converter. To check if your battery is really charging or not, you can measure current in any of these wire. I am using my multimeter to measure the current, make the value 0 and grab any one of the wire, and you can see the battery is currently drawing around 1 ampere of current. It's 960 milliampere. It means it's drawing around 1 ampere. The current value is showing negative here due to the wrong polarity of the wire. You can just flip the direction of the current to get a positive value here. It does not matter. So it means our battery is properly charging. Let's check the battery voltage after some time. So after 2 hours of continuous charging, let's check the voltage of the battery. At first, let's check if the battery is still charging or not. Make it 0, clamp it here, and you can see the battery is still consuming 177 milliampere of current. It means the battery is still charging. Let's check its voltage. When we had started charging our this battery, at that moment this battery's charge was 11.41 volt. Now as you can see, this battery's current voltage is 12.25 volt. It means less than 2 hours it increases 11.41 volt to 12.25 volt. It means you can charge larger capacities batteries than this using the same solar panel and this same buck converter. So this was a small video on a Loom Solar 20 watt panel, how to use the solar panel, how to use a buck converter with it, how to run direct DC appliances from a solar panel, how to charge a battery using the solar panel. Presentation of this video was not that much good because I am not in Kolkata, I am out of Kolkata. As you can see, this is a small town area, this is my hometown, this is Bangla. So that's it for today. Maybe the next video will be on a Arduino project, Arduino DHT22 based Bluetooth enabled humidity or temperature sensor, or I will make a video on RTL HDR. I will introduce you with RTL HDR and ham radio antennas. Actually, if I want to introduce you with RTL HDR, at first I have to talk about ham radio antennas, because without antenna you will not get any kind of RF output from RTL HDR. So maybe I will make the Arduino project at first. Actually, that is a Arduino and DHT22 based Bluetooth enabled humidity and temperature sensor, which sends the real time temperature and humidity data to your mobile. Actually, I made that for my camera boxes. As you know, DSLR and mirrorless cameras are pretty sensitive to humidity, and due to Kolkata's high humidity I had suffered a lot with my cameras, so I had made that temperature and humidity monitor. Actually, ready-made temperature and humidity monitors have a very high price, and I think my DIY version is better than that, and I will make that module once more for one of my photographer friend. I will use this kind of Arduino Pro Mini for this project, because for prototype purpose Arduino Uno is good, but if you want to make a small final product, then this kind of Pro Mini is the best option, I think. So that will be the next video maybe. I hope you had learned something new from this video. If you like this content, please like this video and do subscribe my channel. Hi, I am Akash, call sign Victory Uniform number 3 Hotel Alpha X-ray. I am an electronics and communication engineering student now, and I used to make videos on microcontrollers like Arduino, ESP32, ESP8266 or Raspberry Pi. As a ham radio operator, I also make videos on ham radio stuffs like radios, walkie-talkies, antennas, RTL, SDR, and also on some 3D printer and 3D printing, 3D modeling, stuffs like that. So do subscribe my channel for those upcoming videos. Thank you. And my English is not that much good, but I hope you can understand what I am trying to say in this video. So that's more than enough. This is for today. Bye.